All right, here we go. Now we've got reflection in the line of y equals x, which if here's your xy coordinate, um, then you've got y equals x right there. So coordinate plane, y equals x. What's going to be happening here is that the x values and y values are going to be switched when it is reflected across the line of y equals x. So where you start off with y equals f of x, now we're going to have x equals f of y. And so yeah, all your x values, x comma y values, coordinates are going to become y comma x coordinates. And let's take a look at these ones. So um, we've got the line y equals x here in red. And here's our graph of y equals x squared. And when we reflect it across y equals x, all the points are going to come to the line and then get reflected across on the other side. So this point here, which is 1, 2, 3 diagonal spaces away, then 1, 2, 3, we should have that point right here. And let's go ahead and take a look at that. So here's 1, 2, 3 away, and 1, 2, 3. There's that point, just as predicted. And everything's reflected right across y equals x. Okay, so clearly this one is not going to be symmetrical. Let's go ahead and take a look at y equals x cubed. And you can see that it's probably not going to be symmetrical here either. We got some points that are going to get reflected. That should appear right here. And then the line's going to kind of curve out here. Here it is specifically. And so that green line is the reflection of y equals x cubed reflected across y equals x. And then wanted to get one that did reflect and was symmetrical, and so I graphed y equals 1 over x. And here that is. We just talked about that one today in class of what that graph looks like. It was our first example of a horizontal asymptote. And as it's reflected, notice that it's symmetrical. All the points, as they are reflected over y equal x, appear just kind of on the other side of our hyperbola here. And so this is this one is symmetrical across the line y equals x. And let's look at specifically how we find that. So to see if something is symmetrical across the line y equals x, you switch x and y, and if there's no change, then it is symmetrical across y equals x. So let's look at the one we just said was. So y equals 1 over x. And we're going to substitute x in for y and y in for x. And if we can get back to y equals 1 over x, then it's symmetrical. So instead we'll have x is equal to 1 over y. 1 over y. And actually we get blue parentheses just to be explicit about it. So here, let's say I would multiply both sides by y, which would give me y x equals 1, because y divided by y is 1. Here I want to get x, or get y by itself, so divide both sides by y. And we're left, or sorry, with, not by y, but by x. So divide each side by x, which leaves us with y, because x divided by x is 1, leaves us with y equals 1 over x. And we're back to our original function. So it is symmetrical. We substituted our x and y values, solve for y, and it was the exact same function. Hence, it is symmetrical. All right. Lastly, we have reflection in the origin. So we're going to reflect across a point. Now, specifically the point 0, 0. So here's our graph, and there's the origin right there in the middle at 0, 0. And as any point is gets reflected across, it's going to travel 2 and an equal distance the opposite direction, and it will reflect kind of like that. And so what will specifically will happen here is that for y equals f of x, we're going to have y now equals negative f of negative x. That we're plugging in both a negative x and a negative y. So x comma y becomes negative x, negative y. And let's look at some of those reflections. So on y equals x, Now it's every point on here. Let me actually get rid of that line now as well. Every point on here is going to travel to the origin and travel an equal distance the opposite way. Here is that graph. And now at first that might look very, very similar, and in fact identical, to when we reflected the parabola across the x-axis. But something a little bit different is happening here, and I'll try to make that explicit. That the point A, let me make a new point. The point right here, now D, before when it was reflected across the x-axis, became the point that's down here now as E. It just reflected just the y value became negative. What's happening now, however, is that it's traveling to the origin, being reflected an equal distance over here. And so as it's reflected about the origin, D is now turning into F over here. And really you would call it D1 or D2, the reflection point, D prime. So there's y equals x squared. Let's take a look at y equals x cubed. And if it's reflected about the origin, here's what that one's going to look like. It's identical, because any point that was on here traveled an equal distance the opposite way. And so y equals x cubed is actually symmetrical about the origin, when reflected across the origin. And let's take a look at why that would be. So the test for symmetry for the origin is that you're going to plug in negative x in for x and negative y in for y. So if we started with y equals x cubed, let's plug in equals, and we're going to plug in negative y and negative x. All right, well that gives us negative y equals negative x cubed is negative x cubed, and if we multiply both sides by -1 or divide both sides by -1, however you like to think about that, we end up with, well, negative by a negative is a positive, so y equals x cubed. And here we are right back at our original function. So it is symmetrical about the origin. All right. Yeah, again, hope this helped, and really highly recommend that you grab GeoGebra here. It's a free download, but it can give you some good practice of just kind of moving some points around. So if we had the reflection across the that axis and across XY, and maybe, hey, I wonder what happens when I have a line that's reflected down here, and you can just move that around and get some really good practice and kind of build some intuitive feeling about what reflections do and what happens with them. So very highly recommend that you download that program and just type in the functions. Reflections are up here in this part right here. You would type in the function down below and just play around with it a bit. I think it'd be really, really beneficial to you. All right, hope that helped.